Hello everyone, I'm Bradley Sward, and this is my solution to day 5 of the 2025 Advent of Code festivities. I'm solving both parts of the problem in this video. The problem is called Cafeteria, and I'm solving it in Python, as I almost always do for these kind of problems. So the problem is as such. You have a bunch of ranges of values, so 3 to 5, 10 to 14, 16 to 20, 12 to 18. And the goal is to find, at least for part 1 here, how many of the numbers that come after the line break here, how many of these numbers fall in one of the ranges, at least one of the ranges. So the 1 does not because there's no range there, the 5 does, the 8 doesn't, the 11 does because it falls there, 17 falls there, and 32 doesn't. So you end up with how many of them? 3 for our case. And you can see that my solution gets me 611 as I show. And this is how I do it for part 1. So I basically, when I find a line break, I break out because that's part 1 of it is set up the data, set up the ranges. And so basically I strip out the dash, and then in the left-hand number and the right-hand number, it's always lower number goes on the left, higher number goes on the right. They never switch it up the other way on us apparently. And so I just take and I just convert those into integers. So 3, 5, then 10, 14, 16, 20, 12, 18. And then everything that comes after the line break, I just go one by one here, and I go, well, is this value greater than or equal to this guy, the left-hand side, and is that number less than or equal to the right-hand number? Is it in the range inclusive on both ends? And if it is, add 1 to the sum. And if I go through all of these and I can't find it, well, then I don't add anything. But if I find one, I break out so I don't have to go through more of the loop than I need to. So for part 1, the answer is 611. So for part 2 then, here is part 2. And so the answer is this big, large number here. Here's my code that handles that. So let me describe what I'm doing, and I can show you in Excel. Oops, I don't need to use Excel, I can use anything, but I just want to show you the process of what this code does. So in this case, the second part of everything is irrelevant for part 2. We're just using this first part where we have our ranges. And so essentially, let me pull up my Excel worksheet. Okay, so here we go. So let's take a look at this on this end here. These are the 3 values that can work out. 3 to 5 doesn't have anything that matters here. But the idea here is that when I go through this and I look at this 10 to 14 and then the 16 to 20, in this case, these don't match up. These are separate ranges. Okay, so how about I look at 10 to 14 versus 12 to 18? Let me bring it up higher so we can make. And so the goal here is to say, okay, I'm looking at these two, and they share a range, right? 12 fits between 10 and 14. So the idea here, what I did was, so basically here, I'm going through all of these I's and J's. I'm testing every one against every other one. And I'm like, in this case, I found something that the range exists here. And that's what this does. Basically, what I do is I set it up so that the smaller of the two, like whatever this first value is, this goes in front of the other. So 10, 14, 12, 18. Let's just call this the I value and this the J value. And so, maybe it's easy to do capitals, so at least you could, whatever, stupid font or whatever. But it's okay. So it's saying that, okay, so if this value, I swap if I need to, the I and the J values, that's what this is doing, it's swapping, so that the smaller of the 2 first values is this, it goes in the I value. And then it checks to see, is this value in the range? And it is. So therefore, I don't have to touch this number, but I do have to modify this number here. And this number, so what I'm doing is basically, this is moving over. This is the confusing part, right? So what am I doing here? This number is going to become the larger of these 2 numbers, because this number, like the 12 is already in the range, and it's already greater than this number and less than this one. It's just a matter of filling in this number here with the larger of the 2, because now this becomes an 18, and then I can delete this from the record, because now the 2 ranges combined into one range. And then when I do that, I break out of my loop, and then I do this again and again and again until I can't, and basically until there's no more ranges that can be merged. So like in this case here, the 10 and the 18, and then the 16 and the 20, well, the 16 fits in here. So now we know we can do this. I leave the lower number here in the I range, the higher number in the J. The 16 fits in here, so we don't have to do anything, but the 20 will now move over into here because it's the larger of the 18 and the 20. We get rid of this guy, and now it's all reduced to 10 to 20 like it does in the puzzle here, right? Let me just, because it's 10 to 20, 3 to 5, and then 10 to 20. That 3 to 5 never makes it. I just wanted to show you how you could reduce 3 ranges down to 1 range. And again, just to kind of prove everything goes, it takes just almost instantaneous there to get both parts our solution for this problem. There's my 611, and there's my 3 blah, 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 6 value there. So that is my solution to day 5. As always, if you have any comments, love to hear it, or a better way to do it. I know I could speed this up even more by figuring out a way to break out of both loops, not just one when I find a solution. I believe I can just put a continue or else continue here or something like that. I looked into it just to see how I could, break out of multiple loops in Python. But in this case, it's still fast enough. I'm happy enough with this to say that I'm good to go. I'm ready to move on to day 6 in 23 hours. So that was fun. Fun problem. Not necessarily easy, but it just clicked for me today. So anyway, thanks for watching videos. Thank you for watching this one. We'll see you guys in the next one sometime in the future. Have a good one, everybody.